Continuing on for our previous lesson on functions, where we're finding the hypotenuse, so we need to call that square root properly. Then we need to have another variable here to receive the hypotenuse and put it equal to the function which is on the right hand side. And of course we must change the return type from void to double. And then we need to return from our function our c. And perhaps we could just write out the value of z and try that. And that returns our hypotenuse of 5. Just as a variation of that, instead of using this crudely multiplying them together like that to square them, we could use that math function to raise them to a power. It does become a bit cumbersome then, really. This is a squared and b squared, and then finally getting the square root, of course. I'll now discuss passing by value and passing by reference. These are quite tricky topics, and they could be left till later on. You could come back and look at this later. But let's return to our previous program where we were passing a value, 3 in this case, was being passed to j, and then we're simply writing out the value of j. And that gives us, of course, the value of 3 as being written out. What I'm going to do now is make this a variable here. Int I, for example, equals 3, and then I'm going to pass the actual variable I instead of the constant value itself. And that should do the same thing. It should write out the value that we're going to pass to it. What I might try and do now is just to increase the value of j and just run that, and of course you should find that that's got the value of 4. So that looks all fairly innocuous. Let's try running this with a breakpoint. You could run it down to here. Then if I F11, you can see that the value of I is 3, and if I pass it to, if I F11, you'll see that it's passed now to j, and now j is increased, becomes 4. I'll write out the value of 4 onto the console, and then if I continue to single step, it goes back. Now if I hold my mouse on the I here, it says I is 3. Well, you may well expect that, and that's a fairly obvious thing to say, that I is going to be 3. But we'll be in for a surprise in a moment. I must emphasize at this stage that we are not returning any values at all. We are only passing values to a function. What I'm going to do now is to proceed this with ref. Now let's see what happens in this case. If I put my breakpoint here and then I run my program, now I is going to be passed. Let's see, it's got the value of 3, and it's being passed to j, and now j gets increased to 4, and then we write out the value of j, so that's no problem. But now when I press F11, I return, but look what happens here. I has now got the value of 4. It's been increased. That's the meaning of by ref. By ref means when you pass the variable and it gets changed, as it does here, the value which was passed gets changed as well. Quite strange behavior, you might think. So So let's just revert to what we had before. We had no ref here, and this is what we call passing by value, where the original value which is passed doesn't get changed even though the value that you pass it to gets changed, and that's sort of normal behavior you might expect. It might be interesting to look at our I and j variables in memory. You'll recall how we get the memory windows and the watch window. And we're going to find the address of I and j, so I'll type in ampersand, which means address of, and I'll find the address of j as well. You'll see that the address of I, what I'll do, I'll copy that. I might actually paste it in here as well, so I can but I'll paste it certainly in the memory window. And there you are, you can see the value of 3, the integral value of 3 there, which is convenient. Remember, it's written backwards. So now if I single step, I should now be able to see the address of j, which is here. So if I copy that and paste it in here for reference, the point is that they're very different addresses. I've already seen the value of I, which is here. So I've just resized the window so you can see 4 bytes at a time, because now if I take a look at the next address, which we said was A160, you can see that here, A160. So you can see that this is the position of j and this is the position of I. Now what's the point of this? The point is that I and j have separate memory locations, and that will mean whatever happens to one does not happen to the other. They are independent. Let me now go back to passing by reference. We're going to find that I and j occupy the same memory location. So now let me run it down to that breakpoint and take a look at the watch window. You can see that, well, I is not the same as it was before. It will keep changing all over the place actually. But I'll just make a record of it. And then if I continue to single step by pressing F11, we should find the value of j. And what do you notice? The value of j is identical. So if I go and take a look at the value, the address here, let's make sure I copy that into the memory window. There you have both I and j occupy the same position in memory. So whatever happens to one will happen to the other. We've seen how we assign a value to I, and then we can pass that by reference to our function, indeed pass it to j. What about if we try to initialize j inside our function? For example, putting j equal to 1. and that means we won't be initializing I at all. Will that work? Well, you can see it won't. It's already complaining that here that a local variable, use of unassigned local variable, so that doesn't work. But what we can do, we can just sort of build that to confirm that that's not working, and giving us error messages. So it looks like that can't be done, but indeed it can be done, but we need to use another keyword, and that's using out instead of ref. And now you'll find that that does indeed build, at least. And then we can run it down to our breakpoint, and then if I do an F11, you can see that J has been given the value of 1 in here, and notice when it returns from the function, if I hold my mouse on the I, it says that I has been initialized to 1 as well. Passing by reference can be a bit confusing at first. So here we are passing our variable by reference, and the variable gets, well, it's changed to 1, for example. And that means the original value of I will also get changed to 1. If we compare that really with returning a value, which is a completely different operation, you're actually returning a value from the function explicitly, returning it, in this case, back to I. Completely different techniques, but they take a bit of getting used to see the difference. So we really ought to study them in detail to see the difference. We have here a simple function passing the value of 1 and writing it out. Can we have another function of the same name? Yes, if it has what we call a different signature. So in this case we're going to be passing 2 variables to this, so we could call it from here using, for example, some other numbers, and we might as well write it out as well, the value of J, that is. Let's just see if that builds. And we can run that, and you can see that it's printed out the 1, and then it's also printed out the 2 and the 3, so that's working fine. Perhaps we could single step it. This is where C++ or C# rather would differ from C, in that we never used to be able to do this, have more than one. This is called a signature, when it's got the signature in this case is 2 integers, and in the first case is an integer. And also the signature consists of also the return type as well. So the functions have got 2 signatures, different signatures. So if I run that down to the breakpoint, and then if I now press F11, I can see which function gets called, and indeed it's the first function, and that gets written out. It comes back to here, and you can see that now the second function has been called, and it will write that out. So which function gets called depends upon the signature. These functions are what we call overloaded. We can overload them with regard to type as well. So rather than having, we could have, for example, a float, and then write out the value of the float. And then when we're going to call it, we could call it passing a float value. Once again, the signature is different. We have an integer signature here and a float signature here. So if we were to run that, you can see that the integer function gets called, and now the overloaded float function gets called. So the function which gets called again depends upon the signature. Does passing by reference have any use? Well, let's consider this problem. We have a variable var1, it's got the value of 3, and var2 got the value of 4, and we could print these out. So if we run our code, it should give us that the value of var1. var1 is 3 and var2 is 4. What I would like to do is to write some code here to call a function which will swap them, and then I want to just print them out again. But what I want to do is have them printed out in the other order. That is to say, I want the 4 and the 3 printed out. So at the moment that doesn't work, of course. If I run that, it's going to just print out 3 and 4 twice in that order. I want to have a printout which says var, the second line is going to read var1 is 4 and var1 is 4 and var2 is 3. That's what I would like to have instead of them both being 3, 4. So that's the task that you should have. I want you to write a function which we'll call swap down here. It would look like this. That's no secret. A swap function looking something like this, and that function ought to swap the two values around. Now we've already seen some code to swap two values around earlier in the chapters, but I want you to place that code into a function and work out how we can print out the values here so that they are in reverse order. Now there's no cheating going on here, just putting var, printing them out in reverse order, so putting this equal to var2 and var2 here, that'd be var2, and that would be, I would consider cheating, and this one is var1. So you have to have them so that they're in that order, var1 and var2. That is the task. So have a go at it, but come back and look at the video to see how it's done. Well, we're going to need to call our swap function and pass our variables. And so we need to have the same corresponding signature here. And then, if you might recall our code to swap, and you might recall that that destroys v1, so we need something to hold it, and then to complete the swap we need to say that v2 is equal to our stored variable. The question is, will this work? Well, you could try it, and it doesn't. Why not? Because these are at the moment passed by value. It means that the value of var1 and var2 will not be changed permanently. You could try that yourself. So what do we need to do to remedy that? We need to make them pass by reference. And now if we build that and run it, you can see that the values are permanently changed. var1 and var2 are changed. So you see, passing by reference does have a use, and it is a quite important use, because this function a function in general has a limitation, and the limitation is when you try and return a value, you can only return one value at a time. Do you remember when we had return for returning a function, returned something or other here? Then it can only return, well, it wouldn't be appropriate to use it here, but when we did use return, then we can only return one value at a time. So this is effectively a way, when we pass by reference here, we're effectively returning two values. Well, we're not returning at all, we are changing the originals. And that's the meaning of passing by